Welcome to the Data Hall YouTube channel. We have started a series of lectures on how do we perform a categorical variable regression in R. In our first video, we discussed what if we have a single categorical variable, how would we perform the regression, creates its margin and margin plot. In our next video, we discussed what if we have a categorical variable that have more than two categories, how would we interpret them and how would we create a graph, Marginsplot. And in this video, we are going to discuss what if we have a multiple categorical variable in our regression, how would we interpret the results and how would we create the Marginsplot. And then we are going to discuss within, again, the same video, what if we have a categorical and a continuous variable, how would we create the regression analysis, how would we perform the regression analysis and create the Marginsplot. In next video, we are going to look into two-way interaction, and then we would have a video on a three-way interaction. So let's discuss about the packages that we are going to use. We are going to use the GG effect and tidyverse package. I have already installed them, so I'm not going to use this line of code. I'm just going to load the libraries. Then we are going to load the data set. We have created this sample data for the purpose of this video. It contains different individuals, their age, their marks, their salary, their gender, and the level of education that they have. Now, we are going to interpret and perform the regression when we have two categorical variables. But before we do that, we would have to tell R that these are categorical variables. And we know from our data that gender and education are categorical variables. But let's check the structure of this data. Now you would see that some of the variables are considered as integer, and that's fine. But this gender and education over here are considered as a character variable. That means are considered them string variables, are considered them text, but they are not text, they are categories. So what we need to do first is tell R that these are categorical variables. So we take the data and mutate across each education and gender variable, convert them into a factor variable. So we have a whole video on how to work with factor variables. If you want to, check the link in the description and learn about the factor variables. So if I perform this, if I execute this code and show you the structure of the data, you would see that now gender and education are converted into a factor variable. Gender have two levels, that is male and female. Education would have four levels, that is bachelor's, master's, secondary level of education and primary level of education. Now, if you were to perform the analysis, the regression analysis, we use the LM function. We take our dependent variable and then we take education and gender as independent variable. The independent variable are separated by a tilde sign, and we take the data frame, perform the regression, and let me show you the so I misspelled the model. Let me show you the results. Now we have the results over here, and so in gender we have two categories, but we only see the results of male, because the reason is that if you are aware of dummy trap, the dummy trap is that when you have two categories, you would include only one category in the regression. Similarly, if you have four categories, you would include three categories in the regression to save yourself from dummy trap. So we have one less category, and what would happen to the results of that omitted category? They go into the intercept. So the omitted category in this case is bachelor's level of education and female. So this 3104 represents the predicted salary of a female with a bachelor's level of education. How much a master's? These are differential coefficient. These all are differential coefficient. And what it means is that a master's degree holder earns $33 more than a bachelor's level of education. Similarly, a male earns $35 less than female, the omitted category. So when we have multiple categorical variable and we want to plot them, we would plot them separately. So let's first plot gender and then we would plot education. So we use GG predict, take the results of this model, and for each category of the gender variable, generate the marginal effect. So let me execute this, and if I can show you the marginal effect, it tells us the predicted salary for each gender, right? And then we take these values and plot them and create a Marginsplot. Let me execute this command and you would see that this Marginsplot is created. So we have taken these margins and we have put x-axis, the categorical variable on x-axis, and the predicted values from the margins on y-axis, created a geom point object, and this is how it would look like. It tells us that male earns less salary as compared to female. For education, we would do that, the same code, and we would create the marginal effect, and you can see that we have these plot for different level of education. Now, if we have a continuous variable, let's use a categorical and a continuous variable. Let's create this model, execute this model where we have a categorical and continuous variable as our independent variable. Let me show you the summary statistics. Now, age is interpreted independent of other variables, obviously. And what this shows us is that for each year increase in age, the salary would increase by $5. This negative sign with the male category shows that male earns $31 less than the female, and the predicted salary of female with zero level of education is $2,948. Now, if we were to make it predict what is the predicted salary for a male at the age of 35, use the predicted function, use the model, and create a new data frame where we want to have a predicted salary of male at age 35. So if I can execute this command, show you the value that we have. So we get the male with age 35 should have a predicted salary of $3,093. Now, if we were to plot, we cannot plot the single value on a graph. We would have to create a sequence of observations. So let's predict salary for male from age 35 to 40. So we create a sequence from 35 to 40, and we again use the predict function. And now, instead of having just only one value, we input this sequence of values from 35 till 40 increment by 1. If I execute this, let me execute this one first. And if I execute this, we get the predicted salary of all these different ages. If I can create a data frame of these and plot them, then we get a plot where we can see that there is a positive impact of age on salary. Similarly, we can perform this analysis for gender. Let me execute this analysis once again. Let me create these sequences again, perform these. Now, if we were to create these lines for each of the gender category, then we would have to predict these salaries for male and female separately. So we would have to use this predict command twice. The rest of the command would remain same, except we would swap this male for female in the second command. If I can show you the result, these are the predicted salary for male at different level of age, and these are predicted salary for female at different level of age. I can create a data frame, and then I can bind them and plot them, and now you can see that we have two lines for each category, and we can see that they both have the same slope, but their intercept is different. So I hope this video was useful. Stay tuned to this channel, because in our next video we are going to discuss two-way interaction, and then we would have a discussion on three-way interaction. So do subscribe to this channel and do hit the bell icon. Thanks for watching this video.